Good afternoon, everyone, and welcome back after lunch. I'll try to give an overview of the wind system modeling, a bit brief introduction to just set the floor for more insight of this wind modeling by our renowned panelists that are going to present on the wind system modeling, different aspects of the wind system modeling. So the outline of the presentation is wind turbine generator types, wind power generator models, level of details, then standard wind turbine generator models, aggregate models of the wind power plants, and little bit about the wake effect on the wind power plant models. I think this is pretty much familiar to everyone. So a little bit about the types of the wind turbines. We have 4 types of wind turbines. It started with type 1, type 2 wind turbines, which were these induction generator based wind turbines, which were followed by variable speed wind turbines, wind turbine type 3 and type 4, which are currently in the market. But still there is a at least in some countries, significant penetration of type 1, type 2 in the system. The first question is the purpose of modeling. Why is it so important to have the models of wind turbine generators? If we try to see which all are possible stakeholders of this, or which are the potential users of the wind turbine models, I'll start with first the research community. They need to have a highly accurate model of the wind turbine, different types of wind turbines or wind power plants to do various relevant research studies. Then we have, of course, operators, transmission system operators, distribution system operators, manufacturers as well. Now this wind turbine modeling can be divided into one is the modeling part, and second is validation part. Once the model is up, it has to be validated, and again the wind turbine modeling can be divided into 2 types. One is generic modelers and other is detailed vendor specific modelers. So we'll try to go deep into a little bit deep into how these generic models and vendor specific models fulfill the requirements of various end users of the models. So these are like brief introduction. We have aerodynamic model of the wind turbine, mechanical system model, electrical system model, and it's also very important what is the study that we do, and we have to use the model accordingly. For example, if we are going to do EMT analysis, electromagnetic transient analysis, harmonic analysis study, then we have to of course have much more, little bit more detailed modeling of the wind turbine. If it is RMS system stability study, then probably we may not need to take into account the entire electromagnetic transient part into the account. Same goes for, let us say we are doing some steady state analysis, so we don't need detailed modeling which is actually necessary for EMT analysis or harmonic analysis. So it is also very important that what type of study we do, and we have to select the model accordingly. And I don't think we can have a single model fitting into all these possible studies. Again, this chart gives a bit overview of the level of the complexity in the modeling as we go from modeling the switches of the power electronic converter to power quality, system stability, power flow, and energy balance analysis. I'll start with this so there are so many wind turbine models that have been proposed, but I have tried to capture the main wind turbine models that are widely used. One is, for example, GE model. The pioneer is Sting here, and Miller was the one who proposed this G model in 2003. Then we have Andrel models, which were mainly dynamic for dynamic studies, type 1, type 2, type 3, all 4 types of wind turbine models. Then we have one more model proposed by Fortman and others, which has been used in IEC 6140027 wind turbine model. So Professor Paul Sorensen will give more details about this IEC model and what are the new changes that are being proposed. He will also talk about this IEC model is mainly focused on wind turbine modeling, while as he is going to talk about the wind power plant modeling as well as the new changes in the publication of these IEC models. So we are going to have a detailed analysis by our panelists here during the track. So as I already mentioned, we have different types of models focused on the different aspects. And for example, this Fortman model has come up with a generic type of model which was validated against the measurements, and there are other further details of it. I think given the time we may not be able to go deep into it, but as I mentioned, it was used in developing the IEC wind turbine models. This is so there is WECC models as well. So we have this. If you see here, IEC, we have for all the four types of wind turbines, we have this IEC model. This is, for example, for type 3, where we have control, aerodynamic, mechanical, generator system, electrical equipments, and the grid protection being modeled into the system. And depending on the type, we model the components accordingly. For example, in type 4, we have again type 4A and type 4B. In type 4A, we don't model the mechanical system, while as in type 4B, we do model the mechanical system depending on the application of the study. So then we have WECC type 3, type 4 as well. So coming quickly to this wind farm modeling, there have been different attempts to model the wind farm, because wind turbine, there is a lot of difference between the wind turbine and the wind farm characteristics in terms of when we go to the modeling. So why do we need a equivalent model of a wind farm? For example, in some studies which are at the system level, where you have to model a lot of wind farms, and your study is, for example, dynamic study, it just becomes impossible because of the computational burden and the complexity in the system. So we try to have an equivalent model of a wind farm, so that we reduce the computational burden and the complexity of system while still retaining high accuracy of the detailed model. So aggregation approaches have been many: equivalent circuit aggregation, probabilistic, fuzzy, and others. And we'll listen more about modeling of wind power plants in the presentations to come. Yeah, so this is one of the study, if you see on the left side, just trying to validate a wind farm model and a detailed wind farm model and an equivalent wind farm model. For example, at the wind farm level, you have, if you try to see the dynamic analysis of a wind farm, each wind turbine is, for example, for a voltage event, each wind turbine is going to see different voltages compared to the other wind turbines within the wind farm. So when we try to model an equivalent system here, equivalent power plant of this wind farm, we need to capture those issues into the equivalent model. Similarly, wake effect that we are going to talk a bit in the next slide is also one of the important points we should take into consideration while building up a model of wind power plant. On the right side, this is a small study we tried to see how the characteristics or the response of a wind farm is going to differ when we change the modeling approach. So it is very simple equivalent model we designed as number of parallel turbines, parallel machines, and parallel transformers, and then we took a detailed wind farm of 100 megawatt. So if you see here, the response to the fault is different, because we didn't capture the voltage difference that will be seen by different wind turbines in a wind farm. We just took the parallel combination of parallel machines and the parallel transformers. That was not captured. At the same time, the wake effect and other issues were not captured. So we need to be we need to consider those always when we try to form an equivalent model of the wind power plant. So wake effect, as I mentioned, is also important to consider in the modeling of a wind power plant, especially as I mentioned, one is like if it is a small system study, we can go for detailed model of the wind farm, but at the same time, if we are going for system-wide studies, we have to rely on the equivalent power plants of the wind farm or wind power plant. Yeah, so I think that was a brief overview of the modeling aspects of wind turbine as well as wind power plant that I tried to highlight. Different aspects need to be taken into account, and also harmonization of different models. Like we have number of models in place. So can we work towards harmonizing these different models and come up probably with less number, or maybe in the best ideal case to be with a single model that can be a generic model that can be used and use it in the studies and other applications. Yeah, so thank you.